As a kid, I dreamed of being an adventurer and stepping through the looking glass, like Alice. And in my research now, I use a looking glass, one of the biggest mirrors in the world, to explore the galaxy. You can see it in this photo here. This is the Very Large Telescope, and it's an 8-meter mirror, so it's the size of this room. And you can see how perfectly smooth the surface is by how well it's reflecting the telescope dome. I use this telescope to take extremely zoomed-in photos of nearby stars. We then remove almost all of the starlight from those images. That's important because it means that we can see incredibly faint sources of light very near the star. For example, a planet orbiting around the star. I spend most of my time picking out interesting targets, analysing our images, and improving our image processing techniques. And in September, it all paid off. I made my first discovery. You can see it in this image. This is a debris disk. It's a ring of dust and comets, like the asteroid belt in our own solar system, but around a star much, much younger than the Sun. Just to orient you, the star is hidden behind that grey circle in the very centre, and the debris disk is circular, but it's almost edge-on, so the strip of light that you can see is the front edge of that circle. I'm interested in these debris disks because we think they should be related to planets. The same boulders that crash together to produce the dust in the debris disk could also come together to form a planet. So planets should be more common in dusty systems. But even further, the gravity of a planet will make those boulders more likely to crash together, producing even more dust and making the debris disk even brighter. So planets should be the most common in the brightest debris disk systems, and I'm trying to prove that link in my research. Another way that planets interact with the debris disks is that they can actually scoop up all of the dust and the comets near where they are, which means that they'll carve out a gap and leave two separate rings of debris. I worked with some collaborators to find a relationship between the size of the planet and how long it takes to clear out that gap. And that's important because we can use that to constrain a system, because the planets have to be big enough to have cleared out that gap within the lifetime of the system. This image shows a second debris disk that we've detected. This one is much, much fainter than the first one, but hopefully you can make it out. We don't know yet why the dust is in such a thin ring so far away from the star, but we're working to understand that at the moment. The final image I'm going to show you today is the one I'm perhaps the most excited about. We're not sure yet, but it's possible that this blob of light is a planet orbiting a faraway star. I've got some more work to do over the summer, but if it goes well, maybe I'll have found not just Wonderland, but a whole new world.